We are ready for exercise 2 on domain and range on the handout. We have this graph. So we have this graph of a function, and we want to describe its domain and range. To make it a little easier for this video, I copied the graph and enlarged it a bit. So that's the same picture, a little bit larger. And we're going to go through the same process that we went through in the previous exercise here. So let's just maybe make sure that first we're going to describe the domain. So we want to describe the set of all x-coordinates of points on the graph. We'll be able to describe this with an interval. And the way we can visualize that is to take points on the graph and project onto the x-axis. If we're below the x-axis, we project up. If we're above the x-axis, we project down onto the x-axis. So notice the very first point I'm going to project onto is right here. And the x-coordinate of this point is -5. I want the x-coordinate, right? So I'm projecting onto -5. And then I project onto the x-axis from above and below, all the way over to here, where I have an open circle that projects onto the x-coordinate 8. In between, I project onto every point along the way. So in red now, I have a number line graph of the domain of this function. I have to translate this now into interval notation. I have an interval from -5, and -5 is included, so I write a square bracket, comma, all the way over to x equals 8. 8 is not included, so I use parentheses. So there's the domain of the function whose graph is pictured. Now let's go ahead and do the range. I drew another copy of the graph. Again, you don't normally need two pictures because you could write on the same picture. I just want to make sure in this video you can see the difference between what we're looking at for the domain and what we're looking at for the range. So for the range, we're going to take the same graph, but we're going to project sideways onto the y-axis. So if we're to the left of the y-axis, we have to project to the right, straight across. And if we're on the y-axis, we just stay there. If we're to the right of the y-axis, we project from the right to the left. And again, we can project onto something, notice that we've already projected onto parts of the y-axis, all the way down to here. It's like we're flattening it onto the y-axis, like mush. And sometimes we overlap ourselves, right? So here where we kind of turn back, notice we just start overlapping again, and this open circle is going to just end up in the middle of all this somewhere. The smallest y value we project on is right here. That's a closed circle, and that's a y coordinate of -6. And we project it on every single point from there up to, now don't worry about the open circle because we already colored in that point. We can't uncolor a point that we've colored in already. And we color in all the way up to 0,3 here. That's a closed in point. Y coordinate is 3. That's what we care about. Now to describe this as an interval, think of it sideways, smallest to largest. So in interval notation, we always write the smallest number first, -6. Largest number to the right, 3. And in this case, we have square brackets on both because both endpoints are included. There's the range for that function. So I don't know, I can kind of get domain and range there in the same view. That's exercise 2. Let's go right on to the next exercise. We're going to do exercise 3, which is similar, and maybe just a slight variation on graphing here. I recopied the picture. You can use the picture on the handout yourselves, but for video purposes, I recopied it here and blew it up a little bit. And so we need domain and range. And again, I drew 2 separate copies to make it easier for me to talk about it here. And this is a funny looking kind of a function graph. It is a graph of a function, one function, but it's in pieces. It's called a piecewise graph. We're going to talk about these just a little bit later. Now let's project onto the x-axis. So it's easy to see here, 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 here. Now what happens at -2? We have a point and an open circle, but the point gets projected down. The open circle can't undo that, so we include. When we're below, we project up. At 2, we have a point, so that gets projected. The open circle can't undo that. And so here, I think you can see -4, 5, 6, 7. This is -7. 4, 5, 6. This is 6. We're including this endpoint, and I think we've hit every single x-coordinate in between. So the domain is square bracket -7, comma 6 square bracket for that function, the domain of x values. Let's look at the range. And now we're going to project sideways. I can start here. Sideways, sideways, sideways. Again, the open circle just gets kind of covered over, so it doesn't create trouble there. And now I get down to this point, but then I have this straight line graph projecting over, and I project over from the right to the left here. Now here's an open circle where I do get an open circle on the y-axis. There's no other point overlapping with that. And then we have a gap, and we come down to -4, and I have a closed circle, and I project over. So this range is a little bit more subtle, and I have a closed circle there. So I have a piece of the y-axis down here from -4, 5, 6, 7. Is that -7? That's -4. It's already marked on the y-axis. This point is -2 on the y-axis, and so we have that gap, but then we have an open circle, and we have a stretch of the y-axis that we include all the way up to a closed-in circle point there. So when I think of this in terms of interval notation, now I'm going to turn it sideways, I have 2 pieces. So this range has to be described by 2 intervals. The first extends from -7 to -4, and they're both in square brackets. They're both included. That's the piece below. Then we have a gap, but then we start up again. So we're going to write the union symbol, and I'm going to put -2 in parentheses because the -2 is not included. But every number after that is all the way up to, I guess I didn't mark, all the way up to 5, right? And 5 is included. So that range is a union of 2 interval pieces. It's still a portion of the y-axis. You could call it 2 pieces, but it's the range of our function. So there we go. So there's the domain, and there's the range. And what we're going to do next is we're going to start figuring out the domains of functions just by looking at formulas with no graph.